Alright, so today I want to make a short video about some log rules. So in class we saw that the natural log of a is equal to some number x, that's really saying the same information as e to the x equals a. So for instance, if I said, what's the number log of 5? That's the same as saying, well, it's the number such that if you do e to that power, you get 5. Now this feels a little tricky, right? I agree with you. This is a tricky concept, but I just want to point out that you've seen this before. With let's say with cube roots. So you've actually seen this before when you took cube roots or square roots. So if I said, well, what's the cube root of 5? Well, I don't know. I'd love for you to email me and tell me how you would describe the cube root of 5. But the best way I know how to describe it is to say, well, if x is the cube root of 5, then I know that means if I cube x, I'm going to get 5. Right? So I can't really give you a better description of what cube root of 5 means other than it's the number so that if you cube it, you get 5. Similarly, if I were to say x is the square root of 6, that's the same as saying it's the number such that if you square it, you get 6. Right? And so we're used to talking about square roots and cube roots with relation to functions like x cubed and x squared. So when we talk about logs, they're in relationship to the function e to the x. So let's write this one more time. So natural log of a is equal to x. That means that x is a solution to e to the x equals a. So let's do some examples. So what would, if x equals the log of maybe e to the 4th, well, that should be true. Let's use our formula. So if x is a log of a, then that should mean e to the x equals that number a. So what was a? Well, it's this, in this case, e to the 4th. So that must mean x is 4. So x is 4. Okay. So what we just computed was that the natural log of e to the 4th is equal to 4. And that's one rule of logs, that if we take log of e to any power, maybe e to the b, that's just going to be equal to b. So some people like to say that natural log and e to the x undo each other. Right? I like the word undo. So it means if we first take e to the b and then we take natural log, we just get b back. So these are actually what are called inverses of one another. So inverse functions are really important things to study, and we'll see some other examples of these in this class. So that's one rule, that if we take natural log of e to the b, we get b. And actually a similar rule is that if we do e to the natural log of a, we just get back a. Right? And this is the same reason that natural log and e to the x are inverses, are inverse functions. Okay. So that's one important thing to keep in mind. And the other main property of logarithms that I want to talk about is just how logarithms reflect the rules for adding exponents. So let me just do something. So if I were to write down something like e to the x times e to the y equals e to the x plus y, I bet you'd be okay with that, right? If I'm multiplying two things with the same base, then the exponents add, right? Well, let's try this again. So let's try it again. Let's say if x equals the log of a and y equals the log of b, well, again, this should mean that e to the x is a, this should mean that e to the y is b. And now, well, let's see what happens. If I add the left-hand side, I'll see that x plus y is equal to log a plus log b. Okay, let's remember that. But meanwhile, on the other side, if I multiply these together, I should get e to the x times e to the y is equal to a times b. Well, that's pretty cool, and I know how to simplify that left-hand side. That's equal to e to the x plus y. So let me write this all on one line. E to the x plus y is a times b. Oh, but that's another one of our log rules. If e to some power is a times b, then log of a times b had better be equal to x plus y. Let's do that one more time. Since e to this power x plus y over here is equal to a plus b, then that must mean that that exponent x plus y is the log of a times b. So I've got two things in circles now. And look, they're both equal to x plus y. And so that must mean that these are both equal. And so that means that log of a plus log of b has to equal the log of a times b. So this is what's sometimes called the rule for adding logs. So adding. So if I take log a plus log b, that's the same as the log of a times b. And there's another rule for subtracting, so maybe I'll just put them together. The rule for subtracting, which has a very similar derivation, says if I do log a minus log b, that should be the log of a over b. Okay. So these are important rules to know and to be able to use. They're extremely useful. Understanding exactly why they're true. If this video kind of appealed to you, I think it'd be great for you to try and get out a sheet of paper and try to follow along and try to write this down yourself. I think it might help a lot of things click. But I wouldn't say the derivation is super important. But I think getting more exposure to this material is probably good. So I guess let's do one example before we close. So let's just try to simplify. So let's simplify something like log of 2 plus log of 3. Well, we'll do a couple examples. So our rule for adding two logs says if I add log of a plus log of b, it should be log of their product. So this should be log of 6. Let's do another one. What if we did log of a plus log of e to the 4th? Well, I guess it depends on how we want to combine them. On the one hand, we could combine them this way and say that's going to be log of a times e to the 4th. That would be completely correct. Another way would be to simplify the last term and say log and exponent should undo each other. So this second term here should be 4. So we should have log of a plus 4. And then let's do one final one. Let's do log of, I don't know, x squared plus 1 all over x times y times z. Some crazy expression like this. And again, we can say, oh, well, if I wanted to, I could just say, well, that's the log of the numerator minus the log of the denominator. And if I wanted to keep going, I could keep this like this. And then log of x, y, z, well, that should be minus the log of x minus the log of y minus the log of z. And what rules did I use? Well, let me flip back to the previous slide. I used that the log of a sum, the sum of two logs is the log of the product, and the difference of two logs is the log of the quotient. So I use that quotient here. That's where this minus sign was coming from. And And then how did I get xyz? Well, that's the product of three things. And so I'm going to get the sum of 3 logs. So thank you for watching. As always, leave comments, ask any questions that you may have. Thanks.